Hello, warriors. This is Miss Lemons, and today we're going to be talking about the double replacement reaction lab and how it's set up. So, of course, before you get to your lab, you want to make sure you pull back your hair if it's touching your shoulders, tuck in your hoodie strings, roll up your sleeves, and put on your goggles. Keep your goggles on the entire time you are at your lab station, and if they become foggy, come see your teacher for some anti-fog spray. Step away from your lab station, or if they're uncomfortable, step away from your lab station, adjust yourself, and then you can go back. Okay. All right. So when you get to your station, you're going to find two things. You'll find a reaction grid and you'll find some dropper bottles. Okay. These dropper bottles contain all of the chemicals that we're going to need for all 3 days of the lab. You'll notice that our reaction grid is also divided into 3 days or 3 parts. So we're only going to be using one set of boxes each day. To read the reaction grid, I know this is backwards for you, but to read the reaction grid, each box is numbered, and those are called the reaction box numbers or the reaction squares. So in order to use the reaction grid, you'll notice that on the top we have reactant 1, 2 of them listed, and on the side we have reactant 2 listed on the side here. And so if we wanted to do the reaction for reaction square 1, we would simply take FeCl3 here and AgNO3, and then we would just combine them here like so. Likewise, for reaction square 2, you would take FeCl3 and lead 2 nitrate, and then you'd combine them here in this box. Okay. All right, a note about the droppers. So all of these droppers contain all of the chemicals you need for all 3 days of the lab. The molarities of these solutions are actually pretty low in concentration. So if you get them on your skin or on your clothing, it's not going to burn you right away. But if you were to leave it on your skin for an extended period of time or on your clothing, it could cause chemical irritation, minor chemical burns. So let's just avoid that. If you get a little droplet on yourself or on your clothing, just make sure you wash it thoroughly with soap and water. If you spill an entire bottle, that's something for the teacher to know. So just let your teacher know. We'll come over and we'll clean it up. No biggie. Accidents happen. Just be careful. All right. Okay. So every single day, you are going to only be using anywhere between 4 and 5 of these bottles. You'll notice that the bottles have colors, and those colors correspond with the color on the tape, right? So the dropper and the tape typically match. Likewise, right here, right? We got white tape, white top. And the reason why I have this color code like a Looney Tune is because you cannot switch dropper bottles. If you switch droppers and you accidentally use this dropper inside this bottle, you will contaminate the solutions and you will ruin the lab results for all of the other students that use this set to come. So if you do accidentally cross-contaminate bottles, I mean, I don't want you to, but let me know so that I can at least replace the solution for the next class, okay? So please be super careful. All right, so when we are performing our reactions, we are looking for one of 3 things. We are looking for the production of a solid, a liquid, or a gas, okay? Production of a solid is called a precipitate, and we can see a precipitate if we see a cloudy substance, kind of like murky water. We know that we've produced a liquid if we form a molecular compound and we see no observable change. That's going to look like the production of water, clear. And then the final one is the production of a gas. And we know that a gas has been produced when we see bubbles form. So in your lab, you'll notice that you are asked to place 2 drops onto your reaction grid. Now, I'm just using 2 different substances that are listed here, so this is not the actual reaction. You're going to place 1 drop on the black portion of the grid and 1 drop on the white portion of the grid. Now, at this point, you want to make sure that you take down your observations of what this looks like before the reaction takes place. Now, the reason why we're doing black and white is so that we can see good contrast, because sometimes you can see things better on the black or the white, depending on the mixture we are creating. Now, the second thing, when we add the second drop to this grid, we want to make sure that first, of course, we want to, oh, come on, there we go. We want to make sure that we are taking down our observations of what this solution looks like before we add it to our grid. Now, when you add it to the grid, you absolutely do not want to touch the tip of the dropper bottle to the droplet that's on the grid already. Because remember, you can contaminate this dropper bottle, and if you do, you'll contaminate the solution, which will ruin the lab. All right, so then you want to give it a little bit of air. You don't want the droplets to touch while they're still attached to the dropper. So we're going to get a little bit of air. You want to make sure you do this kind of slowly because these drops are really small. And so the observations are going to happen relatively quick and they're tiny. So make sure everybody's paying attention and you do this kind of slowly. Make sure everyone's ready and you can drop it, a little bit of air. You'll do it twice, paying attention to any potential changes that we see. Now, right here, because I have really no observable change for this particular reaction, I would say that this is the production of a molecular compound because it's probably water that's being produced. Again, I'm not doing FeCl3 and AgNO3. This is just a random set of safe chemicals that I have picked. So then you make sure you write down those observations. When you are all done, oh, and another thing to mention, do not mix any chemicals together that aren't listed on the grid. Okay, there are potentially harmful combinations in here. I picked two that worked okay together. Do not go rogue and just do whatever you want. Only do the reactions that you are given that day, okay? So for cleanup, you can either rinse this sheet directly into the sink, or you can take a little bit of spray, carefully spray it, and then just wipe it off with the paper towel. Make sure you wipe down your entire station. Put your bottles back in. Make sure the lids are on snug. They don't have to be crammed in there, but just make sure that they're on tight, that all of your lids are twisted on, and reset the station for the next students. All right, that's it.